So an activity must always lie between some two nodes all the times. So how we got about the total float is we take the latest event time of our event marking the end of that activity, and we also consider the earliest event time marking the beginning of the same activity, and again we have to consider the duration of the activity. If an activity is critical, like a good example, our activity A here, then at no point should its total float be equivalent to anything else other than 0. Reason, we have got no time to delay a critical activity, because by definition, any small delay or a big delay happening on a critical activity, definitely it would mean the delay of the overall completion time of the project. So it is important that we consider hopefully I can provide a good life for them because of this business. So I've muted all of you so that we can hear each other. So that is one of the frauds which we do compute. And if I take you back again to the document I sent you on the definitions about the frauds, total fraud is a period of time, normally called the space-time or a slack, that an activity can be considered to be delayed or to start at a later date without affecting the overall completion time of the project. There could be so many reasons as to why one would want to delay an activity. For example, the scarce of the resources like the manpower, which could be key in a certain project, would, for example, make you to have a consideration that today it's not the day I want to start this activity. Let me allow about 2 or 3 days that when I start the activity, I'll still be able to complete the project on time. However, if the activity is critical, there is no time to delay it at all. Its total fruit is always supposed to be 0. If you get something else, and by definition, when you drew your network diagram, you had already identified the activity to be critical, then remember you should go back and make maybe a correction onto your work, because a total float for a critical activity can never ever be anything else other than 0. Okay. If an activity is non-critical, a good example activity B here. Activity B here is a non-critical activity. Would want to compute its total float. This was activity A. Let's see what will happen to activity B, which by definition was not falling in our critical path. The activity B lies between event number 1 and event number 3 here. How do I compute the total float? I'm going to consider 12 as the latest event time of number 3. Then I'll minus 0 as the earliest event time of number 1. And I'll also consider to subtract the duration of the activity known as B here. And let's see how much would be our space time. 12 minus 0 minus these 2, the duration of the activity, giving us a value of 10. What does that one mean? Activity A was critical. Total float is supposed to be 0 all the times. A non-critical activity class can never ever have a total float of 0. If you do get a 0 here, something is not okay. It should always be something else but not a 0. And it will always exist. That total float should always exist in case the activity is non-critical. Let's see what will happen to an activity like B, which we said is critical activity. To compute its total float, how do we go about it? This is 15, the latest event time of number 4. We minus 8, the earliest event time of number 8. And we minus 7, the duration of the activity in question. So we take 15, we minus 8, then we minus the duration of the activity, which is 7. And as you can see, as a result of activity D being critical, the total float again is supposed to be 0. If we get something else, something is not okay. Let's see what will happen to an activity like E here, which was an uncritical activity. To compute the total float for activity E, what do? I'm going to take this 17 here. Then I minus 2, the earliest event time of number 3. And then I minus 5, the duration of activity. The duration of activity E. And as you can see, this one is going to give us a value of 10. Again, reason as to why we get a non-zero value here is because activity E was a non-critical activity. So how do we get the computation of the total float? Always remember an activity must lie between some two circles known as the nodes, known as the events. So the latest event time of your number 2 minus the earliest event time of number 1 minus the duration of that activity, giving us the definition of what we call the total float. And we have said this is the amount of space-time that an activity can be delayed without affecting the overall completion time of the project. Okay? So, class, we try and manage our noise. So far, have we understood what we mean by the total float and its computation?
Yes.
Good. Now, the challenge was by many, how do we go about distinction between the free? How do I compute the free float? Let's see how we are going to do the computation of the free float. And I'll pick both the non-critical and the critical activities. Let me start with an activity like A. A free float is an amount of space-time that an activity can be delayed without affecting the space-time of a subsequent kind of an activity or the activity that will actually follow. So how do we compute this particular float? Activity A, let me use activity A as an example, is again lying between node number 1 and node number 2. How to compute the free float of activity known as A from our illustration? We are going to take the earliest event time of the event marking its end. In my case, I have event number 2. And I'm going to subtract the earliest event time of number 1. Then again, we'll also subtract the duration of that particular activity in question. So the free float of an activity A is going to be given by 8, and I'm taking this 8 from the earliest event time of number 2, then I'll minus the earliest event time of number 1, and I'll also consider to subtract the duration of that activity, giving us an amount of space-time, the one we are calling the free float, equivalent to 0. Why 0? Reason again, this is a critical activity. At no point should we delay it, because if we do delay the critical activity, definitely to delay whatever are the subsequent activities in the project. So the time called the free float should always be 0 in case an activity is critical. How about an uncritical activity? Two occurrences when we compute the free float for an uncritical activity may be expected. Number one, it is not a must that the free float for an uncritical activity be a non-zero value. It may happen to be a 0 value, which is okay. I repeat, if we have an uncritical activity, we don't have an expectation that the value cannot be 0. It can happen to be 0, and that is okay. Again, we may end up in our computations having a free float for an activity that is non-critical to be a negative value. But we all know negative time doesn't make sense in an economy. So the assumption is that if you ever compute a free float and it happens to be negative, then you assume that it is 0. However, again, the free float for an uncritical activity may turn to be a non-zero value. I repeat my 3 considerations. 1, the free float for an activity may turn to be 0. It's not a mistake, it is okay. Again, the free float for a non-critical activity may turn to be a negative value. It's not a mistake. If at all your network diagram is well constructed with the earliest event time, the latest event times in the nodes computed carefully, if that is in order, yes, it may happen that the free float computed for an activity can be negative. And if so, you're supposed to assume the value to be 0. Number 3, the free float for an uncritical activity may happen to be a non-zero value, which again is okay. So those are the 3 cases to which in your computations of the free float for an uncritical activity may arise. But I've said also, if the activity is critical, like in our example activity A here, then at no point should you get any other value other than 0. So let's try and compute the free float for activity B. How do we go about the computation of this free float? I'll pick these 2 here, which is actually my earliest event time of number 3. And I'm going to subtract the earliest event time of number 1 here, which is 0. And I'm also going to subtract the duration of activity B in question, giving us a free float equivalent to 0. But we are saying it is not a must that it turns to be 0. If it's something else, it's okay. If it's negative, you again assume it is 0. So free float of an uncritical activity can be 0, but it is not a must that it be 0, like in the case of a critical activity. Let's try for an activity, for example, can pick, for example, activity, let's say, which activity, G here. Let's see what will happen when we compute the free float for activity G. I'll pick this 19 here, which is actually my earliest completion time of that activity, which is also the ET of event number 7, which is a value of 19. Let me make it better. Here we have 19. And I'm going to subtract the 15 being the earliest event time of number 4. Remember, G is lying between number 4 and 7. So I'm going to subtract 15, the earliest event time of number 4. And then we also subtract the duration of the activity in question. So as you can see here, we have 19 minus 17, giving us a value of 2. So a free float, it's not a must that it be 0. It can turn to be anything else, which is actually okay. So I've unmuted you to give me any concern about the computation of the free float before we start on the independent float. Have we understood on how we compute the free float, class?
Yes.
The free float is computed as the earliest event time of an event marking the end of the activity minus the earliest event time marking the beginning of the activity, and then we have to consider subtraction of the duration of the activity in question. So if we have understood this, kindly, I would want to hear from you. How would I compute the free float of activity known as H here? Somebody? How do I compute the free float of activity H? We are computing the free float.
15.
19 minus 15.
15 minus 4.
We have 19, good. Minus?
15.
Minus 15.
Minus 4.
And then we minus 4. And as you can see, this will give us what? 0.
0.
Yeah.
0.
It will give us 0. This is 19, 0. And you can see H is not critical. By definition, it was an uncritical activity, but the free float has turned to be what? To be 0.
0.
So those are the 3 cases that may arise in case of an uncritical activity. For this diagram, I don't see a negative coming by for a free float of an activity. But if it happens to be there, we have said you assume equivalent to a 0. So if we have understood how to go about the free float, now allow me to introduce the independent float. So for the remaining activities during our free time, remember, you work on the total as well as the free float. Let me mute everybody. So let's work on the independent float. Let's use this space here. And as I did it on this, again, the considerations as far as the independent floats are concerned, by definition, an independent float is the amount of space-time that we can allow, or rather we can delay an activity in the project without affecting the space-time of a precedent activity, or whichever we call the predecessor activity in the project. So how do we go about our computations of the independent float? Just like the free float, independent float will behave in the same manner, but they are different, as you can hear from their definitions. So independent float, one, for a critical activity, we cannot get any other value other than 0. It's supposed to be 0 all the times. Then for a non-critical activity, it may turn to be 0, it's okay. It can also turn to be a non-zero value, it's okay. If it's negative, again, the assumption is that you take it to be a 0. So let's start with the computation of independent float. The independent independent float, I may start with an activity like A, which is actually a critical activity. Activity A lies between these two nodes, again, number 1 and number 2. I'm going now to take, you can see what I'm trying to circle in my illustration. 8, the latest event time of the earliest event time of number 2, sorry, and we minus the latest event time of our number 1 here. I repeat, the earliest event time of number 2 minus the latest event time of number 1, and then we minus the duration in question. So we are going to have 8, we minus 0, and then we minus 8. And because this was a critical activity, the expectation is that the independent float is supposed to be 0. No other value for a critical activity. Let's see another critical activity like F here, and we compute the independent float. The independent float for F will be given by what? I'm going to take this 24 here, which was the earliest event time of number 8, which is 24. I will minus the earliest event time of, or rather the latest event time, sorry, of number 5, which is 15. And I'll also subtract the duration in question, which is 9. And it will give us, again, a result of 0. Reason, this was a critical activity. No other value is actually expected because we have got no any amount of time to which a critical activity can be delayed. How about an uncritical activity? Again, an uncritical activity may have an independent float of 0. It may turn to be negative. If so, you assume a 0 value, and can also turn to be a positive value other than a negative value. So a good example, let me pick an activity C. We haven't used it in our illustration so far. And C being an uncritical activity, what is our expectation as far as the independent float is concerned? If we get a 0, well and good. If it's not, again, it's okay. So we have 15, the earliest event time of number 5. We minus this 8 down here, the latest event time of number 2, and then I'll also subtract the duration in question for the activity which we are considering. So we have 15, I'll minus 8, and then I'll minus 3, giving us a value of 4 months. So as you can see, C being an uncritical activity, it is not a must that its total, or rather its independent float be 0. If it turns so, it's okay. But if it's something else, again, it is okay. Again, we can try to compute for an activity like I here. It was an uncritical activity. For I, how do I get the independent float? I'm going to take this 24 here, which is the earliest event time of number 8. This is 24. I'll minus 19, this 21 here. I'll minus 21, the latest event time of number 7, and I'll subtract the duration of the activity in question, which is 3, giving us a value of 0. So as you can see, independent float may end up being 0, but it is not a must. For the other activities which we have not touched in our illustration, we can consider to have them during our free time as we get the independent float. So I've unmuted all of you. Class, understood on how to get the independent float?
Yes.
Yes.
Good. If so, here I have an activity G. Can you see my G here?
Yes.
Can see activity G. I would want you to help me understand how to get its independent float. Activity G. How do we get the independent float of G here?
19
19 minus
19
15
minus 15 minus 2.
minus 2.
Which 15 have you
minus 2.
picked? Is it the upper
These
15
are
or the lower 15?
lower.
The lower.
The lower 15. So this gives us a value of 2, which is 19 minus 17. Activity E here, compute the independent float for it.
15
15
Activity
minus 12 minus 5.
minus 12 minus 5. Good. So that is how we compute our total float, our independent float, as well as the free float. So my take is that those who had a problem in the computations of the floats, at least now we can understand. And it is a direction now we take in the understanding of the Gantt charts, which I'll be introducing maybe another time when we will say your class. Is it okay?
Yes.
Now,
Yes.
we are going to stop there. In my next session, which I'll send you next week, I'll let you know when this will be possible, probably Wednesday there. Next week, maybe Wednesday or Tuesday evening, I'll send you a class. Are we together? So that we crash the activities. So before then, you make sure you read through the document on the rules which we follow during the crashing. So class, let's keep quiet those who are talking. If we talk, then we can't hear each other. So we are saying we send you a class next week, probably Tuesday evening or Wednesday, so that we can introduce the crashing of the activities. Is that okay?
Yes.
Yes.
Today I've tried to do a record of our class so that we can share with the rest. So I'll share this with you, and then you can also alert the others who are not able to join in the meeting. But before we leave, could there be any concern that is burning? We see whether we can address that first in our next session. As far as networking is concerned, so far, what can we say?
How can you tell that the value is crashing?
That's what I'm saying. We do it in our next class. But I'd sent you an outline on what to consider during the crashing of the activity. So we make sure we read through those guidelines, so that when we be crashing, we'll not have an issue. Why am I picking this? Why not that? Okay? You make sure you read through that document first before we meet in our next class. So I'm giving you some homework, some exercise for you to do. A small exercise for you to do. Did you read the guideline on how to go about the part method? The computation of the earliest event time, not the earliest, but the expected time, the standard deviation, and the variance.
Yes.
Okay, so that is clear. We need not to go through that. Or what do you want?
It's clear.
It's clear. Good. Do this class so that you'll be able to move quickly in the representation of the Gantt chart. December 2013, question number 5B. December 2013, question number 5B. I'll also post it on your WhatsApp group. You can hear that? Are we together?
Yes.
December 2013. December 2013, question number 5B. You draw the network diagram. Question 2, you compute all the frauds for each activity. You compute the frauds for each activity, activity A all the way to H. The free fraud, independent, and the total frauds. Sawa sawa.
Yes.
Good. So we mark the end of our class today. We'll meet another day next week.
Thank you.
So I end the meeting.
Thank you.
Karibu. And I'm hoping you're doing the MIS questions. Nyamaza hivi hata msemi kama mko sawa.
Go sawa.
Mko sawa?
Sawa, tuko sawa.
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 Okay. So I've ended the meeting. Kwaherini.
Bye.